Welcome back to the garage, everyone. Today I wanted to do a quick video on some options for a first welder for the home or garage hobbyists to get some projects done around the house or shop. And we may cause some controversy over this due to my opinions on which one of these processes I think is the best for the home user. And part of that goes into the fact that your old school guys think stick welding is like the only way to learn how to weld. And then you've got other people that think MIG welding is faster and easier and therefore the better option. Now this video stemmed from another couple videos I've seen where they compare MIG welding to stick welding, and that's not really an apples to apples comparison because MIG welding traditionally uses a gas bottle, and a lot of the things that they were in favor of for stick welding don't apply to flux core wire welding, which is what we're going to discuss today. That takes the gas bottle out of the equation and makes it cheaper and comparable in cost to a decent stick welder. So to start, both of these welders use flux consumables. That means neither of them need shielding gas. So on a stick welder, your electrode's coated in flux with steel in the center, and as the electrode burns and melts the steel, the flux goes with it and creates its own shield. In the wire-fed flux machine, you've got a wire that has flux in the center surrounded by steel, and when the wire melts, the flux melts and creates its own shield. So that makes both of these options good from a cost standpoint. There's no gas cylinder, no regulator, no hoses. It makes them both great for a portability standpoint. You don't have to transport around a gas bottle, and both of these machines are very lightweight. This flux core wire fed machine is a little bit heavier, and that's due to the fact that the spool of wire is stored inside the machine, and then you've got the motors that actually feed the wire through the lead. Both of these machines will run off 110, so there's no power requirements. This one will run off 220 also if you need higher amperages, but both will run off of 110. Both can be used outdoors without having to create any sort of wind blocks or turn your gas up super high. So a lot of the argument for stick welding being the best way to learn comes from the fact that the machine itself is really simple. And what I've got here is a TIG205-DS, which I bought for the TIG function, but it will also stick weld. The only control on here is an amperage knob. So you set your amperage and then you're ready to weld. This is a Harbor Freight Titanium 125. It's a flux only machine, no gas, and it's got two controls on it. One is the voltage, the other is the wire feed speed, so how fast the wire is going to come out of the tip. Both of those need to be set in order to get a proper weld. Now, that makes this machine a little more complicated when it comes to settings. Something that is not often discussed when talking about the simplicity of a stick welder is the different electrodes that are available. So while the machine only has amperage control, these electrodes come in different diameters for different thickness metals. They also come in different compositions that make them better suited for certain tasks or types of welding. So the flux can be different, or the steel inside can be a different alloy. Another thing that I hear a lot is that these boxes of electrodes tell you what amperage to run them at, and that is true. However, this particular box has an amperage rating of 90 to 160 amps, so that is a huge range. This box of electrodes has a smaller range, but it is still 70 to 105 amps. So you still have a 35 amp range there that you need to dial in order to get a good weld out of these. The other thing to keep in mind is that there's AC and DC current and positive and negative. Now with the flux core wire fed machine, you've got wire speed, voltage, and then you do have a couple different diameters of wire. However, a lot of it overlaps. So if you're in the middle somewhere, you can use either size wire. If you get to the extremes, you know, super thick material or thin material, you may need to drop down in wire size or move up to a different wire size. Now, when it comes to the actual process, I find stick welding to be a little more complicated in the mechanics of actually making your weld. So the first thing you'll notice is you clip your electrode into the stinger. This is called the stinger. You need to strike this rod to get it ignited, and then you need to keep this close enough in order to keep the arc sustained, but not stick it to your workpiece. If you stick it, you gotta unstick it, and then you've got to restrike and restart the weld. That doesn't sound horrible. However, when you're going laterally, we're going to use lateral welds as an example here because it's going to be the easiest to show on camera. If you were laterally moving left to right with this, you're moving this electrode along this piece, but your electrodes are also going to get shorter as it melts into your weld. So not only do you need to go left to right in this case, you also need to go vertically up, down. You need to be bringing this across and down to keep this electrode at the proper height in order to continue the weld. When you set your amperage on this machine, that's the amperage in the machine. When you have this electrode out here, you're actually not getting that amperage out at the end here. Now, as this electrode melts down, you're going to get higher amperage at the weld. So you need to keep that in mind as well. As you're welding and you're shortening this piece up, your amperage is actually going higher. With a flux core wire fed welder, the only movement you need to be able to do, once again, going horizontally left to right in this case, is holding this at a steady height and going left to right while you pull the trigger. When you pull the trigger, you're going to be feeding wire and power to this tip, and it's going to continuously feed until you let go of this trigger. So that makes the motion of actually welding, I mean, you do have to have a good tip angle and that sort of thing, but the actual motion and movement you need to do when you're welding is a lot simpler. It's only one thing versus having to, you know, vertical and horizontal. And your amperage, or your voltage and power at this tip is going to stay the same throughout the weld. One of the benefits to a stick welder is that these electrodes can be bent and still work as long as you don't break the core. So you can bend this and you may be able to get yourself into some tighter areas. You know, if you needed to weld up in a corner or something, you can bend these and get your hands in a better position. Now, one of the downsides to stick welding is that when you're starting out, you're already very far away from your workpiece, and it can be hard to brace yourself and be steady. Now, as this gets down, you can see you can start to reposition yourself and get a better position. So with this flux core wire fed welder, people argue that the settings need to be exact in order to get a good weld, and it can be hard to figure that out. Most of the new welders I've seen have inside here, there's a chart right here, and it tells you what voltage to set the machine at, what wire feed speed to set the machine at for certain thickness metals. And it also tells you that for two different wire sizes, the two most common. So all of the guesswork's kind of taken out of this as long as you know what you're working on and what size wire you have in the machine. Now, of course, you may have to make fine adjustments to get you really dialed in, but you're going to have that same issue with a stick welder. Like I said before, these 7018 rods have an amperage rating of 90 to 160 amps. So you may be able to find a chart online that's going to give you, okay, at this metal thickness, you need to be using this rod in this diameter at this amperage. However, you're still going to have to dial that amperage up or down depending on what you're doing. Now, some of the downsides of both processes are the fact that with flux, you're going to have slag and you're going to have spatter. It's just the nature of the flux. Flux produces a lot of smoke, so it's not necessarily great for indoor use unless you've got really good ventilation. Normally when I weld with either of these indoors, I have a fan going and the garage door open. Now with that said, I much prefer the wire-fed flux machine for the type of things I do. Once you get some metal to practice on, which if you need to find metal to practice on, you can check out this video and we'll get you pointed in the right direction there. You can get different thickness materials and start practicing and figuring out the settings, and you can make your own chart for your specific machine using the starting points and then your experience. So in my opinion, if you're doing things like building shelf brackets, interested in scrap metal art, you need to do basic repairs on things like lawnmower decks or appliances, that sort of thing, I don't think you can really beat this setup with a flux core wire fed welder. If you're doing heavy equipment repairs or you live on a farm, stick welding offers some electrodes that are very good at penetrating through rust and even painted metal, and you can get various diameters. So if you need to fill a big weld, a big crack or something in a piece of equipment, you can get bigger diameter rods and fill that quicker without having to do as many passes as you would with this machine. But for your average homeowner use, I believe that it would be less frustrating and easier to pick up the motion of MIG welding or wire-fed welding, even though this has a couple more variables on the machine itself. With this, you can get one spool that can cover most of your home welding scenarios and keep that spool in this machine. This welder cost me right around $200. I forget what exactly it was when I purchased it. This welder cost me about $240, and that is with this coming with a TIG torch, a foot pedal. You know, this is set up to TIG weld, so there's a little bit of an added cost there because it's got the components in there to allow you to TIG weld with the same machine. If you wanted just a straight stick welder, you could probably find one a little bit cheaper than what you can on this. So in my opinion, small stuff around the house, average garage and home use, I would personally go with the flux wire-fed welder. Or if you think you may want to get into MIG welding, get the MIG welder, only run the flux in it until you're ready to buy the gas bottle. You can run flux core wire in a standard MIG welding machine without gas. So there, you can, if you think in the future you're going to get more into metalworking and fabrication, you can buy that MIG machine and get started, add that cost of the gas bottle down the road once you've got your feet wet. Farm use, large projects, pipe, structural steel, I would definitely go with the stick welder, and that'll pretty much have you covered. And you can do the smaller stuff with the stick welder. To me, it's just a little bit more difficult trying to use these long electrodes for short welds and things like that. So I hope this kind of gave you an idea where you should go. I think that flux core welding gets a bad rap from a lot of people, and I don't quite know why that is. But I appreciate you taking the time to watch, and I hope you like and subscribe. And if you've got any questions or comments, put them in the comments below. Thanks.